Okay, linear modelling is just a fancy word for putting straight lines into word problems. So in 3.01 you solved equations, and in 3.02 you solved equations but we had to read the words. It's exactly the same here. We talk about an independent and a dependent variable. Y is always dependent on X. So we'll have a look at this. Jessica's organising an 18th birthday party. The total cost of the party is $300 for the hire of the function, $200 for the music, and $23 per person for catering. The table below shows the cost for a number of guests attending the party. Okay, let's call this X and let's call this Y. We did this in the previous example. It says which value, N or C, is dependent. Well, the cost is dependent on the number of guests, but if we can't understand that, we know that the cost is Y, so it must be dependent. Write a linear function for C in terms of N. Well, we have a table and we need to get an equation. So we need to start with finding the gradient. 15 on 135, 1325 minus 980. $345, 15 on 345. So the gradient is 345 on 15, and I think that's going to give me 23. Because I also can get it from here. It's a rate, 23 per person. Okay, how do I find the y-intercept? Y equals mx plus c. Sub in some numbers. I'm going to choose these ones because they look prettier. No, 1900 equals 23 times 60 plus what? My y-intercept is 1900 minus 60 times 23. I'll work that out. That equals 520, which makes sense because they said the total cost of the party is 300 plus 220. Before they even have any guests, they've got to have a hire room and music. So the equation is cost equals 23 times the number of guests plus 520. If it was graphed, which variable would be on the vertical? C. What does the vertical intercept this function represents? It's always y with no x. So it's the cost, which is y, with no people, because people's x. The cost of the party is 80 guests. Well, this is just subbing in. Cost is 23 n plus 520, and if I substitute in 23 times, how many guests? 80 plus 520, I'm going to get a number.